Hello, you're watching the Green Network Summit, part of our year-round DSP Leaders coverage. I'm Ray Lemaitre, Editorial Director at TelecomTV, and today's discussion looks at the benefits of building a green radio access network, or RAN. Now, the RAN accounts for, on average, about 75% of the total network energy usage for a mobile network operator, and the radio unit is the most power-hungry element, accounting for as much as 80% of RAN energy usage. Now, the physics of radio communications means that these are far from the most efficient systems, but there are many technological and operational innovations that can help to reduce this huge power budget. We're here today to discuss how the RAN can become more energy efficient. And joining me on the program today are Saima Ansari, Senior Partner Manager at Deutsche Telekom and Green Future Networks Lead at Industry Forum NGMN. Joanne Triay, Deputy Director and Network Architect at Docomo Eurolabs and Rapporteur at ETSI's Industry Specification Group, NFV. Francis Haysom, Principal Analyst at Appledore Research. And Sarat Puthempura, Chief Architect of Open Radio Access Network Initiatives at the Open Networking Foundation and the Linux Foundation's Ether project. Hello everybody, good to see you all. Thanks very much for taking part in this discussion. A lot to talk about, so let's get started. So the first question for today is, the radio unit is responsible for significant levels of power consumption in the radio access network, but what are vendors doing to improve efficiency? So Saima, if we can start with you.
Historically speaking, with each generation of the radio networks, we have seen higher efficiencies and the supplies, of course, to the radio units. And actually, there are several strategies that are implemented to improve the energy efficiency of that. If we start from the hardware side in itself, so we will see that we have now the design of the power efficient chipsets, more efficient power amplifiers and other components, which bring down the overall power consumption. From the software point of view, if we see that radio units can dynamically adjust their power output based on real-time traffic demands, for example, during peak hours, the transmit power and the active component can be scaled down while still maintaining the customer experience. We have also seen in the 4G and 5G different types of sleep modes. For example, deep sleep, where most RF and the baseband components of the radio units are turned off during the low traffic period, or micro sleep TX. This is another example to turn off the transmission components for a very, very short duration, like somewhere in the milliseconds or something. When we go besides hardware design aspects or the software efficiency, we can also look into, let's say, things like wideband technology usage, where one single radio unit is covering multiple frequency bands, leading to fewer resources and thereby saving energy. Not to forget, this also means not having multiple boxes, but just one box covering multiple bands, which is again leading to a further lowering of carbon footprint as well. From the architecture point of view, there is also quite some improvements that we have seen. An example there could be, let's say, the integration of the radio units with active antenna units, reducing cabling losses and so on. We have actually focused on this very topic in our latest NGMN publication called A Roadmap to Energy Efficient Mobile Networks. We are addressing their things like passive antenna energy efficiency, or front-end adaptivity for increasing energy efficiency. And this publication is already available on the NGMN webpage, so feel free to check it out as well.
Okay, fantastic. Well, good to hear that that's documented as well, somewhere where people can go and get that information. So, Francis, obviously there's a lot of developments ongoing, but is there more that the vendors can be doing to help with energy efficiency in the RAN?
Well, Ray, I think, to be honest, radio unit is not our core focus. Our core focus for research, and I'll leave others to comment on the technical detail. But I think importantly, we got to realise what is happening is that in order to use the capabilities that the radio unit is doing in terms of energy saving, whether that is to sleep, hibernate, turn off, scale, etc., is it relies on an operational environment that can make those changes safely. Probably automated as well. And I think our biggest challenge in this area is not so much what the radio unit can do, but the processes that would allow that kind of dynamic change that can give us these options to scale up, scale down of energy usage during the day, during the year, depending on energy sources, for example, as well. And the reality is that most CSPs today have very conservative and manual RAN operational processes, and in many cases they avoid change. The stable RAN, to get a stable RAN after change can often take days or weeks to actually achieve, and there's a great deal of trust issues that need to be solved here. So I think we need to understand that if we're going to utilize that new technology, it needs to go beyond just each radio unit scaling up and down. This is a whole network. This is a whole network problem. It's all very well scaling down an RU, for example, but if somebody's moving, you need to be able to bring up capacity, bring down capacity in line with that movement, and often that can take minutes to actually achieve. So you've got to have that operational processes that can bring things up, bring things down. And the last thing I'll sort of say is I think we've been talking about things like tidal RANs for certainly the last 10, 12 years, and there's been very limited operation. And I think that reflects this challenge of the operational process of allowing these newer features to be utilized in a safe and automated way.
Okay, fantastic. Thanks very much for answers. And Joanne, did you want to come in with any additional comments on this question?
Yes, I would like to remark about one of the points that maybe have not been emphasized. It's about the advancements that are being done in terms of the radio configurations. It's not just only about the capabilities that are being nowadays specified and implemented in terms of being capable to switch off and on the component carriers and the RF bands, either selectively, some of them or all of them, but also the capabilities that are being defined to change the configuration of the radio frequencies. And here, for example, some of the latest advancements consider making reselection of the transmission and the reception arrays, or also being capable to change the MIMO configurations or the SBB blocks for the synchronization, or even changing the transmission power of the radio units. And that, together with the specification of the sleep modes that has already been introduced, can also bring up a lot more benefits in terms of energy efficiency, also potentially making savings in energy consumption.
Okay, fantastic. So let's move on now and look at the role of the RAN intelligent controller. How can the RAN intelligent controller, or RIC, help to improve energy efficiency? And which of the two RICs and their associated apps are the most relevant? Sarat, let's come to you to start on this, because I know this is an area where you've been doing a lot of work.
Yes, thank you, Ray. So let's see the fundamental problem that we are trying to solve here. I mean, if you look at the radio access network, we are satisfying or trying to address load which are time varying and position varying on a fixed network. So you really need to make sure that the two facets of the problem, one side is energy saving, other one is maintaining the QoS, the quality of service. So it is a delicate balance between these two. So the way that we we talked about it. I think for example, Simon mentioned it, turning on off of components or the node itself is the way to go, but you need to do it in a very, very I would say surgical manner. So when it comes to RAN intelligent controller, let's talk about the disaggregator architecture itself, the Open RAN architecture. It basically splits the node into CU, DUs, and RUs. So DU and RU are virtual functions, and RU is the physical unit, and then or virtualized core, and then the RIC, both near RT RIC and non RT RIC, and the SMO. So this is essentially the architecture. So when it comes to using RIC, it does give a lot of flexibility to levers to manage the energy consumption in the RAN, even though it is making the architecture a little bit more complex or by disaggregating. And if you don't do it carefully, the energy consumption will, in fact, will go up because there are multiple, servers and other computing and storage infrastructure involved in implementing the CUDUs, as virtual functions. So you need to do it very carefully. But the good news is that we do have enough levers to address or manage the energy consumption without losing performance. So this is a series of studies that are going on by various entities, including in Open Networking Foundation, Linux Foundation, and we do have a grant from NTIA, the government, the U.S. Department of Commerce, to see how the energy consumption is varying among components and an end-to-end, power model as a function of the load. So RIC and associated applications like XApps and XApps are associated with the near RT RIC, which is subsequent actions, and non-RT RIC are associated with RApps, which takes actions, control actions, which is taking a second and more. So when it comes to which application is more relevant, I would say at this point I would go for non-RT RIC because it can you can implement a significant energy savings using RApps on control loops, which taking more than 1 second. So when it comes to advanced sleep modes, as Simon mentioned, by going into sub-second control action, near RT RIC and associated XApps would be extremely beneficial. So I would say for significant energy savings can be achieved using RApps running on non-real-time RIC. And the good news is that with proper adaptation of non-RT RIC and XApp with appropriate interfaces to legacy network, because LTE network is a workhorse today for the mobile communications, and we should be able to manage energy consumption in LTE network also. We have done that, and we have done some experiments, and we have done some practical investigations also on that one. So the short answer is that ORAN does give ORAN architecture does give the flexibility to implement all the sleep strategies that we are out there, and need to do it carefully. And we can start with the non-RT RIC, which and reap significant savings, and move on to near RT RIC and XApps for advanced sleep modes. That's the answer.
Okay, thanks, Sarat. And Francis, from your research of the sector, are you seeing advances in this area with the non-real-time RIC?
I think the question is possibly posing a question that doesn't really exist. Both forms of RIC are actually needed for better energy consumption in the area, and they have distinct roles in terms of achieving that. So I think it's important to say it's not one or the other. It's ultimately both, or the ability to let's be frank about the non-real-time RIC. It's fundamentally analytics and imposition of intent onto the network, and the near real-time RIC is really a near real-time controller for the RAN network, and you need both. I think there's two areas I would call out. One, Sarat mentioned it. This is fundamentally energy consumption and QoS are always in a slight tension. And if you look at today's networks, we all want energy saving, but actually many of the regulatory or the customer QoS things actually tend to favor more energy utilizations in order that we don't break QoSs. The non-real-time RIC, the ability to understand the policy of your company, the ability to impose that intent on the network and to balance between conflicting policies is incredibly important, and that's a big role for the non-real-time RIC. And also importantly, in terms of being able to describe what you are doing as a CSP to your regulators and to your customers, many of whom want energy efficiency as well and want to be seeing how you're trading that as well. In terms of the near real-time RIC, it's incredibly important in terms of actually managing how we can use these sleep functions, these hibernation functions, these turn on, turn off scale functions within the whole of the RAN, in fact, and the ability to drive that in terms of more energy efficient handovers, for example, and many of the other things that happen in the real-time controller will be important. So both are important, and they can enable us to make the transition to a more energy efficient RAN.
Okay, great insights there, Francis. Thanks very much. And Joanne, let's come to you for your insights on the role of the RIC here.
I will be very controversial here because I actually have to agree with both Francis and Sarat. Yeah, I think that there is no clear winner, probably. Both of them are important. However, I would like to maybe highlight the aspect of the non-real-time RIC. And I believe that the better energy efficiency of the RAN is not just only a concern of the actual radio units and the radio configurations, which is where something probably the near real-time RIC can actuate more efficiently, but it is about the whole network deployment. And here we have to consider factors that it is not just only the radio unit, it's also other parts and other network functions that are being deployed, potentially on virtualized infrastructure. So there are many more factors and parameters that need to be considered. And at this scale, I would say that the non-real-time RIC can play a critical role. For instance, there's not only about the proper setup of the radio configuration, it's also about how to consolidate the workloads, how to actually manage the cloud resources, and how to optimize the power consumption on them. And all this telemetry and all this information that can be fed up needs to be evaluated at a global scale. And here probably the non-real-time RIC, as I mentioned, can play the critical role. And one of the things that I believe that is also important to highlight is that there's not going to be a good RAPs and XAPs unless we can also enhance the telemetry and collect as much data as possible from all parts of the network. And it's not only about parameters of data volumes and signal interferences or reference signal powers and qualities. It's also about the actual power consumption of the equipment that is happening, not only the part of the radio, but also on the typical servers that are living in the sites. So altogether, I believe they need to be considered.
Okay, fantastic. And Sarat, I believe you want to come back in and add a few more comments here as well.
Yes, please. Thanks, Ray. So basically, I just want to clarify that both near-RT RIC and non-RT RIC are critical to, they're important for energy saving. They play its own role. There's no contest about it. But I need to bring in the aspect of ORAN adoption here. If you look at the interfaces, the non-RT RIC is interfacing with RAN using an interface called O1, and which is fairly advanced, and the other one for near RT RIC is E2, which is still not matured. So if you want to get some benefits out of, if you want to get some immediate benefit in energy savings, and you go for on-off cell, a complete, the node on-off, you could achieve that with non-RT-RIC is much faster because of the maturity of the interface. And also, you could do some adapters to the own interface and interface that with the I would say traditional RAN through their EMS. We have done that, and we have some quite a bit of data to prove that's a viable option. So all I'm saying that to start getting the benefits of ORAN architecture and the RIC, it would be probably makes sense to start with the non-RT RIC and then progress our way into advanced sleep modes and near-RT RIC and XAPs. That's a clarification I'd like to make.
Okay, thanks, Sarat. A lot of moving parts there, obviously, around the RIC. So we've talked about the radio and about the RAN intelligent controller. But what about other RAN technology improvements that will have a positive impact on energy efficiency? Joanne, let's start with you. What else can be looked at from the mobile operator perspective to help make their networks more power efficient?
Thanks. Well, here I would actually a little bit follow up on the previous question and the answer. And I believe that one of the potential main key drivers beyond purely the radio and the RIC is about the actual disaggregation of the RAN itself and the potential for the virtualization and the cloudification of it. And basically here, the benefits that we can foresee is that thanks to this disaggregation, we can more efficiently redistribute also the network function workloads and potentially, for example, consolidate the resource usage. And besides the actual composition of the network itself in its deployment, it's about the use of the new kinds of resources that we can leverage from the cloud infrastructure. And here we have yet more components which we can use to actuate and improve on power efficiency. Like, for example, if we need to save power or energy consumption by shutting down some of the nodes in on the cloud infrastructure, leveraging also new CPU architectures, like, for example, ARM-based, which are known to provide more energy efficiency in its processing. And also factors like the consolidation of the workloads in specific locations can also bring benefits in terms of, for example, the systems that we need to cool down those servers. For example, here, new technologies on liquid-cooled equipment and also more intelligent air conditioning systems can play a critical factor. So I would say that the other factor, in summary, the other factor beyond the radio and the RIC, I would say, is the actual disaggregation and the virtualization of the RAN. And here is where we can also foresee lots of improvements in the future.
Okay, great. Thanks, Joanne. And Simon, let's come to you. What other technology should be considered here?
Continuing from the virtualized setup that we just heard about, I think that one of the things that I want to highlight once again is the entire idea behind controlling and being able to monitor, right? So if we are not able to monitor, then we are also not able to optimize. There are several tools available. I can give you maybe an example of Kepler, which is a Kubernetes-based energy monitoring tool to estimate the power consumption by tracking the CPU usage. And of course, it's primarily on the CPU energy consumption data, but it also correlates very well with other monitoring methods like IPMI and PDU data. So it provides a holistic view of the energy usage in the cloud-native environments. And I believe that this definitely helps us to understand the power allocation also dynamically and how our workload distribution looks like, and then balance the energy saving with the performance. If I go away a little bit and look from the site perspective and how the sites have been built so far in our networks from an operator point of view, the most obvious choice is, of course, switching from legacy to the latest radio technologies, and I think that it's heavily explored already. One of the things that I can add to it is the modular architecture. That could be another good option, because very often we also see the placement of different passive infrastructure in the indoor units. And if we go from the liquid cooling side, which I just heard also previously in the session, these are good options, but probably not as advanced. And there is a lot of research also going in this direction. But the outdoor cooling, which is also readily available in many areas, could be also used. So looking into the option of modular architecture, ensuring that the placement of different equipments are actually according to the environmental conditions, and then balancing that with active cooling systems also could help in reducing energy consumption.
Okay, fantastic. Thank you, Saima. And Francis, can you provide us with some additional technologies to be looking at here?
I think the key one, and I mentioned it in an earlier question, I think the key technology to getting this right is operational automation. It's the ability to put automation on top of this, to be able to automate change, to be able to automate change in functionality, software, etc., software distribution, and increasingly to be able to automate and put in place autonomy within the RAN. The RAN runs itself to a set of intents. Those will be key to getting this energy efficiency right. Because unless you can do that change, trust that change, repeatedly that change, it's very difficult to see how some of this stuff will actually be taken beyond the science lab and taken into the scaled network. The other area, I think, is the whole area of digital twins. There's a huge opportunity here, particularly as we're cloudifying the network, to do far more simulation of the network and to be able to better scenario plan and chaos test some of these conflicts between what is QoS level and what is energy saving levels. Being able to anticipate those kind of thing, those kind of changes, and being able to automate and then flow that through into configuration of the network. And Johan mentioned it earlier. I think it's the really important thing is truly moving to the cloud in the RAN. At the moment, the reality of what we're doing in the RAN is largely still hardware box tied. A function sits on a box and is sat in a particular place. The more we can decouple that, then the more we have the ability to be much more flexible about how and where particular network loads are cited, and also importantly to be able to use the capacity of the cloud to be able to scale that and to be much more certain about being able to use CPUs and use efficient places, data centers with efficient energy input, to be able to efficiently use those and be able to scale up, be able to be certain, trust in being able to run CPUs compute at a much hotter level. So I think that will also be important.
Okay, yeah, a much bigger picture to consider here than with the sort of the traditional radio access networks. And Sarat, have you got any other examples of technology developments that would help with energy efficiency in the RAN?
Yes, I'd like to add on the comments that Simon John mentioned. So what we are trying to do at this point, the part of the research work that I mentioned with Rutgers University's WILLab, is to get an end-to-end power model, which takes the power consumption of the radio unit and also the virtual network function, and is supporting the Kubernetes and bare metal, and also getting ground truth using PDUs. And what is the minimum set of parameters that you need to measure from the network to get a pretty reasonably accurate power consumption model across all those things? So that work is progressing. The idea here is that once you get a power consumption model, then you can use that to optimize. So some of the techniques that potentially we could use in the server side or the infrastructure side is to reduce the voltage on the CPUs and clock speeds, and also reduce or shut down some of the functions which at low loads, where you really don't want to use. So these are the additional levers that you can pull when you have a good end-to-end power consumption model, and how that model can represent the power consumption under varying type of or under various types of load and then amount of load that is offered to the network.
Okay, great. Thanks, Sarat. Now, another thing to consider is what might be done to improve energy supplies and energy management systems. Do telcos need to forge closer partnerships with energy providers? Simon, maybe we can come to you first on this.
So I wouldn't say it's going to be a surprise that energy is one of the highest priorities in our company. And the fact that we as Deutsche Telekom have already committed to use 100% renewable energy all across our network definitely is a challenge, because we know that it involves many different strategies coming together in play, whether it's on-site renewable energy production or going through the power purchase agreement. It all depends on what is available in which geography that we are operating in. So looking at all those factors, I would say it definitely makes sense to go into closer cooperation. But beyond that, we also look at, let's say, the complication that arises when you are using more and more renewable energy. One of the direct complication that you can see is the volatility of renewable energy, which one of the simplest way to go into looking at a solution could be a larger scale battery storage. Because if you are generating much more energy at a certain point in time than you can use, then you are definitely relying on different battery solutions to support. That's one of the reasons why we at Deutsche Telekom, we took also this decision to install large-scale battery energy storage systems. So we plan to have a total capacity of around 300 megawatt hours, which we also plan to use for peak shaving arbitrage and to maximize the use of renewable energy. At the end of the day, to participate in the energy markets and contribute to the stability of our grid. This is one of the options which we definitely take seriously. Another concept that I see also telcos getting very much familiar with and interested in, which we also see in our Green Future Networks program at NGMN Alliance, is the so-called energy flexibility. So this is the idea of all the telcos basically referring to the ability to adapt to this electricity generation and the consumption, and how to balance that for this specific period of time. And this is evolving at the moment, and I do not see any concrete results there, but definitely it's developing. And if we go in this direction, I definitely see that it will bring us much more closer to the energy providers, and there will be a stronger partnership there.
Okay, fantastic. That sounds like really important work for all parties involved. Francis, let's come to you now. Is this a natural, stronger relationship that needs to be brokered here between the network operators and the energy providers?
I think it's useful to go back to the TelecomTV Great Telco debate in 23. There we were talking a lot about energy optimization in one of the pre-sessions. It's very clear. And I remember I think it was the energy lead at Vodafone was talking about it. There are already very, very strong relationships with the energy providers. And in fact, the biggest lesson from that thing that we took away as Apple Law Research was that there's a huge amount of emphasis in terms of the relationship, which is really about energy arbitrage. How do I get the best price? How do I get the most efficient price? I think the the piece that needs to be brought forward beyond just energy arbitrage is how do we bring this much more technical features like the ability to turn down capacity, etc., and bring that to the energy arbitrage, bring that in terms of the energy sources and bring that together. And that was the thing for us just over a year ago, was that they seem to exist in very different rooms. So if we're going to make that closer partnership, it's probably getting that closer partnership between the energy suppliers, the energy buyers within telcos, and the technology behind it to link into that. I think there are some signs of it. We've seen some examples with Lalisa and Vodafone in terms of making greater ties to green energy, battery usage, for example, at Lalisa. But I think the key partnership is about bringing the sort of the energy procurement part of a telco in line with the technology that could enable better optimization.
Okay, yeah, great point. And just goes to show how useful the great telco debate and associated events are, of course. Joanne, let's come to you next on this point. How do you see the relationship between the telcos and the energy sector developing?
Yeah, as others have mentioned, also critically important. Not just only in the aspect of the procurement of the energy and the power, but actually on also coordinating in between the power providers and the operators. For instance, a very practical use case that we are developing is about how we can actually change our deployment of the network, knowing in advance if there's going to be some shortage of power from the grid. And that brings us new requirements, for example, on getting notifications or events from the power providers and being able to understand where the shortages are going to happen so that we can actually redeploy or change or scale down our network in order to not put more pressure on the power consumption overall. And this is also complemented, for example, on some of the practical use cases of deployment of the base stations that are happening in Docomo right now. We call them the green base stations, and those base stations are equipped with the solar panels and also with rechargeable batteries to actually overcome these potential shortages of power, and at the same time to actually contribute on the generation of energy. So yeah, I would say that these are quite of good practical examples that operators and Docomo here included are working with the power providers.
Okay, fantastic. Great to hear that these kind of advances are being made. Well, we're coming towards the end of our session now, but we're going to close with what might seem an almost impossible question. And that question is, what overall savings are possible for network operators from becoming more energy efficient in the RAN? And how might these figures be improved as Open RAN evolves, and also through the associated use of AI? So, Sarah, maybe we can start with you. Is there any way of quantifying the gains that can be made here?
Yeah, so the use of AI in energy saving has been used even before the Open RAN, but I think it has got a lot of potential. So in the context of Open RAN, it does give a good framework to put AI models to optimize, I would say, various power saving strategies, mostly via prediction. So a commonly used prediction AI application is to determine what should be the sleeping and wake up thresholds, because no two cell sites in a network is the same, because they are operating in different traffic conditions, geographic conditions, and different topologies and in configurations and stuff like that. So the traditional use of AI has been in load prediction, say that, oh yeah, you're expecting the load to go down at this particular time, particular situation. You can start breaking down the components or to bring the node as it is down. And then you keep monitoring, hey, there is something going on, and basically you need to start waking up the components so sufficiently in advance. So waking up and sleeping, especially waking up, the time frame is extremely crucial to maintain a QoS. So AI has been traditionally being using in this context for that, outside and within the construct of the ORAN architecture. So I think the way I would see is that the architecture provides even more greater flexibility to introduce AI capabilities into various energy saving strategies, and I am hopeful that there are more and more applications along that directions will be created by researchers and vendors. So the answer is that I'm very optimistic about it.
Okay, thanks very much. Joanne, is there a way we can look at this and measure or predict what kind of gains might be made in terms of RAN energy efficiency?
Well, yes, it's a very difficult question, but I can maybe give a few figures that we are considering at Docomo. In our case, well, I guess that in alignment with many of other network operators around the world, we have our targets for what we call the green targets. Basically, in alignment with many others, trying to become carbon neutral by 2030, as well as zero net in 2040. And to achieve that, we are considering that network efficiency and energy efficiency should be by 2030 at least tenfold, so above 10 times better than it is currently. And to achieve that, we are considering that we should at least achieve a savings in energy around 30% in the radio part, and up to 60% depending on the base stations and also the time of the day. So these are the figures that we are considering. And well, this is also a call for action for the whole industry to try to make it a reality. I'm also aware of some of the exemplary calculations that are being done, for example, in the ORAN community. As I mentioned before, there are different mechanisms to save power by changing radio configurations and so on. I'm aware that there are exemplary calculations that, for example, in installments of up to 10,000 radio units with a common pattern of traffic changes throughout the day, depending on the mode that can be activated, there are potentials of saving thousands of megawatt per year. And it depends also on the kind of strategy that is being followed, whether it is switching off certain RF bands or actually changing the configuration of the RF bands. But there are potentials to actually save thousands and thousands of megawatt per year with the current patterns of the traffic that we have. And maybe these numbers also will further evolve and improve in the future, as I foresee that, for example, new technologies in chipsets will also bring a lot more potentials for saving in the future. So yeah, I think that there are potentials, and as I mentioned, I think it's a good opportunity to also raise the importance of it and a call for action for the whole industry to save energy.
Absolutely. A great call to action, and great as well to end us on some numbers and figures that others can look to and look to try and match or even beat as well. So thanks very much for those insights. We do need to leave it there, and I'm sure we'll continue this debate during the live Q&A show later. For now though, thank you all very much for taking part in our discussion. And if you're watching this on day 2 of our Green Network Summit, then please send us your questions and we'll answer them in our live Q&A show, which starts at 4 p.m. UK time. The full schedule of programs and speakers can be found on the TelecomTV website, and that's where you'll also find the Q&A form and our poll question for this summit. For now though, thank you very much for watching and goodbye.